moving into the next application rate, we will have our medium carryover nitrogen rate application. So in that medium rate zone that we can scroll back up and see of that 145 pounds application across the acreage, we're going to use that as a blanket rate application. So this is going to need a little bit more math in the end. We'll go through and it'll start out very much similar, but when we get to the end, you'll notice we have to add in a little bit more calculation. So in our high carryover area, where we have a lot of leftover nitrogen from the previous year, we'll be a little bit over applying, but we'll still at least be able to meet our yield goal. So we would take our application of 145 pounds, 0.41, times our total amount of acres, which is 8.34, to find that we would put 1,212.72 pounds of total nitrogen across that 8.34 acres. Now that we know that our total poundage, we can carry that number down and divide it by the total amount of pounds of nitrogen in 1 pound of UAN 32 or 32O. So 1,212.72 divided by 0.32 gives us our total required amount of UAN 32 or 32O, which is 3,789.75 total pounds of UAN 32. So now that we know how much 32O we need, we can carry that down, and we have 3,789 pounds, 0.75. We can multiply that by the cost per pound, which we know is 45 cents. So when we multiply those together, we end up with a total fertility cost of $1,705.39. Now we'll save that for later, and we'll use that later in our calculation. In this area, because we are actually over rather than under fertilizing, we will still be able to meet our yield goal. We will take 250 bushel per acre average yield times our number of acres, which is 8.34, and find that we get 2,085 total bushel yield off of those 8.34 acres. If we carry that total bushel number down and multiply it by our December futures cost, we end up with $11,905.35 of gross income off of that area of the field. A reminder, gross means that we have not yet taken the input costs out of our number. So as we carry our gross income number down and subtract out our total fertility cost, which you can see again is marked in gray, we carry that down. So $11,905.35 minus $1,705.39 gives us a total net income for the first zone of $10,199.96. You can see it marked in the red box here and marked by the number 1. As we keep continuing down, we'll have to calculate the medium carryover zone at our medium carryover rate. Because this is the same number that we designed to suffice for this rate, we will still meet our fertility goal. So we have our application required of 145.41 pounds of nitrogen across 8.34 acres, giving us a total requirement of 1,212 pounds, 0.72 of nitrogen that we will have to put across those 8.34 acres. As we carry that number down, we'll have 1,212.72 needed pounds of N divided by the total amount of N in 1 pound of UAN 32 or 32O, giving us 3,789 pounds, 0.75 total 32O or UAN 32 required. Okay, so as we now know how many total pounds of UAN 32 we need, we can carry that down. And then we will multiply that by the cost per pound. So if we have 3789.75 total pounds times 45 cents, which we know is the cost per pound, we find that our total fertility cost is $1,705.39. Again, we'll save this number for a little bit later and have to continue on with calculations. Again, because this is the rate designed for this particular zone, we will still meet that 280 pounds per acre yield requirement, nitrogen requirement for our 250 bushel per acre yield, so we can continue on. 250 bushel per acre yield times our 8.34 acres, we wind up again with 2,085 bushels total yield for that 8.34 acres. We carry that number down and multiply it by our December futures cost to find that we get $11,905.35 gross income. Once we have our gross income number, we can carry that down and then refer back to our number in gray highlight here. We would subtract $11,905.35. Out of that, we would take $1,705.39, giving us a total, again, of $10,199.96 net income. Okay, so now that we've got those two done, we will move down to the low carryover zone where we're going to need a little bit more math. So all the application rate is going to be the same. We're going to put down 145.41 pounds of N across 8.34 acres, giving us a total of 1,212.72 pounds of total N required. We carry that number down and divide it by the total amount of pounds of N in 1 pound of 32O, or UAN 32. So when we divide that out, we find that we need a total of 3,789.75 pounds of 32O, or UAN 32. Now that we know the total amount of UAN 32 we need, we can carry that down and multiply our poundage needed by the cost per pound. So we need 3,789.75 pounds multiplied by 45 cents per pound. We find that our cost is $1,705.39 for our total fertility application. Now, this is where we're going to differ a little bit on this calculation. Because this is our low carryover zone, we actually have less nitrogen already available in the soil. Thus, with our lower application rate, we are actually not going to fulfill our required nitrogen level. So we have to calculate that and find a percentage of our goal that we met and use that to calculate how much percentage of our yield goal are we going to meet. So to figure that out, we're going to take our total required N for our goal, which is 280 pounds, minus our recommended application rate, which was 187 pounds per acre, letting us know that 93 pounds per acre of N is already in the soil. So if we know we already have 93 pounds in the soil, we can drag that number down and add our application that we're using for our blanket rate to find that we would have a total of 238.41 pounds per acre of plant available nitrogen. Since we know that we're only going to have 238.41 pounds of plant available nitrogen out of our total goal, we need to find out what percent of our goal that is. So we carry our number down, 238.41 pounds, divided by our total goal number, which is 280, which gives us 0.851, or 85.1% of our fertilizer goal was met. Because only 85% of our fertilizer goal was met, we're only going to meet 85.1% of our yield goal. So to calculate our yield, we're going to take that number and carry it down of 0.851, or 85.1%, and multiply that by our yield goal, which is 250 bushels per acre. When we multiply 0.851 times 250, we end up with 212.75, which would be our actual achievable bushels per acre average yield. Since we know what we can actually expect to make with the fertility regimen that we used, we can now throw that bushel per acre down here just like we would on any other calculation and multiply that by our total acreage that we are growing. So 212.75 bushel per acre average times 8.34 acres gives us a total bushel yield of 1,774.34 bushel. Now that we know what we've got off of our field, we can continue to drag that down and multiply that by our December futures price and find that we would have $10,184.71 gross income. Again, just a reminder, gross incomes means that we have not taken our input cost out of that number yet. So we have to carry that number down and refer back up quite a ways now to our gray colored number, which is our input cost. So we would bring our gross income number down, $10,184.71, subtract out our inputs, $1,705.39, to find that we had a $8,479.32 net income on that zone of the field. Now, to find our gross margin for this operation, we have to add up our 3 zones' net incomes. So you'll notice down here I have 10,199.96 plus 10,199.96 plus 8,479.32. And they're labeled 1, 2, and 3. So if we look back up at the top, we have our 1, which is our $10,199.96 net income. Our number 2 is the same, $10,199.96 net income. And then our final one being $8,479.32 net income. When we add that all together, we end up with a $28,879.24 gross margin for this particular application regimen. So to find out what our wastage on this application regimen is, we would take our optimum gross margin, which is $31,315.06, subtract out our current application gross margin, which is $28,879.24. That would give us a $2,435.66 wastage.